Hello everyone and welcome to episode 1 of this series where we will be building an RPG game from scratch using C++ in SFML. Now in this video we're going to go over the asset manager. The first few videos of this series will mainly focus on the foundations, as we need a good solid foundation before we can actually get into the game itself. And the asset manager's job for our project, as the name suggests, will be to load assets for use in our project. Now if we just look at the header file right over here, I first define a few enums, for example font, texture, and music ID, also sound effects ID. These are just different categories that make it easier to actually use the class, which you will see very shortly. And as you can see, I have some fonts over here, some textures, buttons, titles, background boxes. Also, each enum has been overloaded to return a string, which will be used for logging purposes. And if we scroll down, you will see that I have file paths for every single asset that we'll be using in the game. Right now, this is not the complete list. Of course, we will add as we go along. But just as an example, you'll see over here we have file path music ambient 1, and it leads to the file path for the music ambient 1. This is just our definitions for our asset manager. But if we go and take a look at the asset manager itself, we will see that it is a singleton design pattern, of course, because there should only be one asset manager in our project. And we have a get instance for our singleton, we have an init which we'll get over, and we have a few getters all overloaded to get our different types of assets: font, texture, music, sound effect ID, etc. We also then get rid of the copy constructor and the move constructors, and we just have the default destructor. We get rid of these because of course we're using a singleton design pattern and there's no reason to have them. We have our private constructor to match the singleton, and we have a few private helper functions which we will get into very soon that actually help with loading the various assets like font, texture, music, sound effect. This takes in the ID for that type of asset and the file path which we defined earlier in our definitions right down here. Okay, let's get into the implementation itself. Now obviously the get instance is pretty standard for a singleton design pattern, but the actual initialization is where most of the work happens. The first thing we do is we check if it's already initialized. We should not try to initialize it again. This is because the asset manager should be initialized only once at the start of our program before anything else runs. This is because if you attempt to use a asset in SFML without initialization, you will get undefined behavior, as I have in the past, and it's not a very fun thing to try to debug. So it's safer to just load all your assets right in the beginning, and it's not computationally intensive because you're not actually rendering all these assets right in the beginning. You're just loading them and making them available for use. Okay, now you'll see that this makes quite a clean pattern where we go off of the success of loading the previous asset. If it's successful, we try to load the next. If it's not, we stop loading any other assets, because obviously if we can't load one asset, there's something seriously wrong with our game. Now you'll see we call these helpers the load font. We give it what type of font we're trying to load, for example, and the path to that asset, in this case the font. These are all used for our maps, which you will see in the asset manager down below. We have a map for each type of asset: a font map, a texture map, music map, and a sound effect map. This makes it easy to retrieve and give ourselves access to these different types of assets. Now if we scroll down, we will simply log if it's successful. It's just so we have a little indication that all assets have been loaded correctly. Let's go over some of the getters. Now, if we want to get the font, of course, if the asset manager is not initialized, what we will do is we will return the default for that asset type. Okay, for the font, that's the default font. Now you might be asking, of course, the default font needs to actually be loaded to return it, but that is the bare minimum that we will expect from our program, that the defaults are always loaded. If they're not, then this will obviously fail spectacularly, but we will assume that at least the defaults are loaded. Okay. If it is initialized, then we find that asset in our map, and if it's not in our map, we fail to get that asset and we log it. That's why we overloaded all the output stream operators for our different types of assets, so that we can see if one is not in the map for whatever reason. And then if it's not in the map, we return the default again. Otherwise, we return that asset to be used. It's also important to note that some of the assets can be changed, like font and texture. You see they can't be changed, like font and texture, they're const. But music and sound buffer can be changed. And the reason for that is because for music and sound, like sound effects, for example, you would want to actually start playing that music or change the volume of that music. And that's why we actually need to be able to change those values, and we can't just return them as consts. Okay, hopefully that clears that up. And you'll see there's the getters for the other assets. They work similarly, getting them in the map, etc. And here's some of our helpers. For an example, we'll go over the load font. First of all, we will make an object of the type that we are trying to load. In this case, it's a font. We will try and open the font from the file path provided. And if we can, this returns a boolean, by the way. If we can, then we just simply add it to our map and we return true, aka it has been successfully loaded to the map. If it can't be loaded to the map, we give a log and we return false, and this will log exactly which font could not be added to the map so that we can successfully debug. Okay, the texture works similarly with the texture. Music works similarly with music, like this. Okay, sound effect also similarly works like this. And that's about it for the asset manager. This is vitally important to do this first in your project, because obviously you're going to be working a lot with assets, and it's good to have an organization like this, because now in future, if you just want to add a new asset, the first thing you do is you add it in one of these IDs. If an ID doesn't exist, you'll need to make a new one along with a new map. But okay, let's assume an ID does already exist. Let's say we want to add a new texture. You will simply add the enum down here. You will overload its string down here. Then when we go into Asset Manager and the Initialize function, we want to load a new texture. So we will add a new line at the bottom. We will choose our newly added ID. And I forgot to mention, we will need to add a new file path as well. We'll go to the texture file paths, add it in the correct section, and give it the exact file path of that asset, so that in the Asset Manager CPP, we can just place it right over there, and we have now loaded that texture to be used for our program. If I just quickly go to the main, you will see that in main.cpp, the very first thing that I do is I get my Asset Manager and I initialize it before anything else. Again, this is the most important thing and should be done at the beginning of every single program that you do in SFML that works with assets. Okay, let's go over a bit of an example of how I have used the Asset Manager. See if I can search for one. Let's go to perhaps menu. Over here in this menu, I make a new sprite. You don't have to worry about it for now. But the sprite takes in an SF texture, so we need to get a texture. So I simply call my Asset Manager. I get its instance for a Singleton design. And I want to get an asset. And I pass it the texture ID that I want. In this case, it's the background for mountains. And this will return an SF texture reference, which SF Sprite takes in. Now, it's important to know that a lot of the assets, like texture, for example, need to persist throughout the lifetime of the object that you're assigning it to. So as long as the texture that I'm passing to this specific sprite right over here lives longer than the sprite does, or they live the exact same time, there's no undefined behavior. And if we go back to main, because we initialize our asset manager and it lives throughout the entire scope of main, which is our entire program, this is always guaranteed, and this is why I choose this design in particular. Okay. Now, again, the first few episodes like this is just going to go over the foundation of the project that is really needed. I know everyone wants to get into the actual game, but we need to go over the foundation, because things like this you can't change later down the line, and you will wish that you had this organizational power in the beginning. So yeah, if you enjoyed this video and you found it helpful, and you want to see more of this series of how we actually create a game from scratch, from nothing, no AI, it's just pure SFML C++. If you enjoy that type of content, please like, subscribe, drop a comment if you have any questions, and I will see you in the next episode. Thank you for watching.